So those of you that are regulars know that I always give an update on our Mars missions, since I'm a Mars scientist by background. And right now we actually have 8 spacecraft at Mars. We have 2 rovers, the Opportunity rover and Curiosity. And as of last month, we have 6 spacecraft operating in orbit. So we'll talk about 3 of those tonight. So the first is an update on Opportunity, and today is day 4,569 since it landed in early 2004. A sol, for those of you that are uninitiated, is a solar day. A Martian day is 24 hours and 37 minutes long, so we call that a sol. These 2 rovers, Spirit and Opportunity, were intended to last about 90 sols. So you can see what we're doing here. So just the background on this mission, they landed in a small crater. And over the last, gosh, what is it now, 13 years, almost 13 years, they've been making their way to this large 20-kilometer diameter impact crater called Endeavour. And for about the last almost 2 years now, they've been climbing along on the rim of that crater. The next slide will zoom in at much higher resolution on this area called Marathon Valley. So this is the rim of Endeavour. If you have really good eyes, maybe you can see this yellow line snaking back and forth. So currently the position of the rover is, I knew this at one point, they're down in this area. Actually, about right here. And so that's what they've been doing. At some point, they're going to climb into this crater, but for the moment, they've been skirting along the rim. These orbiting spacecraft have given evidence that there are clay minerals in this area, and clays are of great interest because they're the type of minerals you get if you expose other types of rocks to water and hydrate the rocks, and you alter the chemistry and the structure of the rocks. And so this is what it looks like looking out the cameras of Opportunity. This was taken about 5 days ago, and they were trying to climb up this slope, and you see all these rocks in the way, and that has definitely gotten to be a problem. Each of these rocks are about half the diameter of the rover wheels, so not a safe thing to try and climb over. Plus, they're on a steep enough slope that they tend to slip. So they've been moving very carefully, trying to sort of move their way through little gaps in the boulder fields. And this was taken just 2 days ago, I think. And this obviously, well, from here, we're looking over in this direction. And this is the path that they actually want to be following, either this way over to there or straight if they could do it. And this is a little misleading. It looks like they've gotten a lot closer, but this is a higher resolution camera. It's sort of like a moderate zoom lens, so don't be fooled by that. But that's where they're essentially sitting right now. And just the quick recap of this mission, it's day 4569. They've driven about 43.5 kilometers over the course of these almost 13 years and returned about 215,000 images. So it's been, over that amount of time, it's a pretty slow pace, but still, they were initially expected to drive maybe 600 meters, so 0.6 of a kilometer, and return maybe about 1,000 images. So definitely still producing very useful science and still alive and well. So we'll be celebrating Let's see, for opportunity, I think it's January 21st will be its 13th anniversary since landing. That's 13th Earth year anniversary. So moving to the other side of the planet, the Curiosity rover landed in August of 2012, so we're a little bit beyond the 4-year point for that, and it's day 1536 since landing. And this is sort of a selfie of the rover. They have about a 2.5 meter long robot arm that sticks out front that has a camera on it, and so they can wave it around and point it back at the rover and see everything but the arm itself. And so that's what it looked like. This was about 6 months ago as it was moving across the surface. So the lay of the land for Curiosity, this is Gale Crater. It's about 160 kilometer diameter crater. And what drove NASA to send this mission there was this large mountain in the center of the crater. It's called Mount Sharp, and it's about a 5 kilometer high mound of sedimentary rocks, so layered rocks. And what they intended to do was target somewhere in this ellipse so that they could get close enough to the mountain that they could actually drive up at least into the foothills. And in fact, they came down smack dab in the center of that ellipse. And once they started looking around, there's Mount Sharp off in the distance. And what's exciting about this is all these layers in the rocks. And geologists get very excited about that because that means there was some sort of episodic creation of the rocks, deposition. It could be mud flowing into a lake. It could be sand ripples, so wind-driven. It could be volcanic ash. But the idea is the lower layers are going to be the oldest, and then as you move up through these layers, you see younger and younger rocks. So you can sample what the environment was like when those rocks were laid down and see how it changed with time in this area of Mars. And backing up, you see quite a few features here that look like water flowed into this crater. And the thinking is that in the earlier, warmer, wetter epochs of Martian history, this was probably a lake, and this would have been a very large island in the lake, and then as the water evaporated or dove underground and got lost that way, you exposed all these rocks. So this is the path that Curiosity has taken. They landed up here. Mount Sharp is down here. You see just barely the foothills. These dark areas are sand dunes, and the problem was they wanted to get here, but they couldn't safely cross those dunes without running the risk of getting stuck. So they've been paralleling the dunes, and just over the course of about the last 6 months, they're now heading up toward the foothills. And this actually is where they are right now. Well, this was about 10 days ago. And you see that this is a topographic map, and so they're moving upslope well, I take that back. Upslope is here. So they're sort of in a little bit of a dip right now, but upslope will be moving this way. And just a few observations from the last month. About a month ago, they came across this golf ball-sized, very strange-looking rock, and it turns out it's a nickel-iron meteorite. And again, just for scale, that's about the size of a golf ball. And note these bright spots here, and this is a closer up view. This is where they used the onboard laser experiment, the ChemCam, where they zap the rock with this high-powered laser and vaporize a small spot, and they're able to measure the composition of the rock without actually touching it. And so they actually did 9 3x3 array. Keep hitting the wrong button, sorry. There's one in here as well, and they were able to determine that, yes, that's made out of nickel and iron. So this is, oh gosh, we're probably approaching about a dozen of these meteorites that have been seen over the course of Spirit and Opportunities and the Curiosity's mission. And they've, just in the last week or so, undertaken a sort of a series of photographs or images just looking at the rover itself. And so this is a little sundial on the top deck of the rover. And at one point, these were different colored blocks that they were using as color calibration for the camera. They're now pretty well dusted with the Martian dust that falls out of the atmosphere. But you can still see that it's still acting as a sundial. The dust doesn't affect that, so it's just a nice experiment. And this was put on the rover by the Planetary Society, and it's used as a means to get school or classes in middle schools through high schools to do experiments with this, of analyze the movement of the sun in the Martian sky. So a couple of other things that, well, one other thing they've been worried about, they have a very sophisticated sample collection mechanism. So this is their drill. This is the drill bit looking straight down. It's sort of a percussion drill. So it's like what you'd have if you were drilling into concrete, where it hammers back and forth at the same time that it's rotating. And it's about the size of a $50 is the size of the hole. And it then sort of has a corkscrew mechanism where the powdered material gets sucked up into the drill itself. And they've been worried about contamination, that they do one sample collection and then they run the drill without being down on the surface and hammer it back and forth and rotate it, and all the loose material should fall out. But if it doesn't, then you've got a contaminated sample. You're mixing material from one drill hole with the next. And so they're doing all of these imaging experiments to actually see if they can detect material hanging out after they collect a sample. And the one thing you can see is there's a little bit of red stuff right here on the end of the drill bit. And so that would indicate that there's at least a little bit of contamination. The one thing they could do, if they really come upon an area that has something that they absolutely want it to be pristine, they can change out the drill bit. They've got, I think, 3 drill bits on board, and I think they're on their second one so far. So they certainly could do that to eliminate some of that. And then this is another sample collection device. It's a little scoop. It's about the size of, say, like a 2 tablespoon, kitchen spoon that you might have. And it can scoop up the powdered material from these samples. It could scoop up sand. And then they have another device that sort of closes over this, and it has mesh in here of different sizes, so they can shake it and sort out the particles. So it's a way to sieve the sample. And just looking at that, there's definitely some material stuck inside that sample scoop, and you have a little bit of it stuck to the mesh over here as well. So what they do have a mechanism on this that instead of just shaking it, they actually sort of hammer it as well. And they're going to experiment with that. reason they don't routinely do that is that's more mechanically, it's harder on the mechanism itself. You're causing a lot more vibrations, and they figure that that would reduce the lifetime of the experiment if they had to do that routinely. So that's what they've been up to, and these are just a couple more pretty pictures. This is the type of rocks they've been driving across for a while now. All of these white veins in the rocks they've measured to be gypsum, which is a calcium sulfate mineral, and that's caused by groundwater welling up through the rocks, and you have dissolved minerals in the water, and they precipitate into the cracks in the rocks. And so here was an image taken just yesterday with one of the hazard cameras that they use for navigation. And there's Mount Sharp off in the distance, so this is the path that they're ultimately driving on. So that's the update for both of those rovers. It's day 1536 for Curiosity. It's just past the 15-kilometer mark, and it's up to almost 380,000 images. And both Curiosity and Opportunity are doing quite well. So they've both been given extended missions. So the funding to keep them running has been approved for another 2 years for each of them. So we expect to have a very busy couple of years.